So, this was Gallup a couple years ago. Headline, U.S. oil drilling gains favor with Americans. Subheadline, support for offshore drilling and oil exploration in Alaska reach new highs. Okay, there we go. From those headlines, can you tell who the population we're studying is?
Alaska.
U.S.
Well, hang on. Who are we studying? Well, actually, you know what? Time out. Maybe I asked the question too soon. Let's go further. Let's go further. First line, Princeton, New Jersey, home of Gallup. 6 in 10 Americans favor increasing offshore drilling for oil and gas in U.S. coastal areas, up from 50% in May 2010. Who are we studying?
Americans.
We're studying Americans. Thank you. I asked the question too soon. My apologies. We're studying Americans and their opinions on oil drilling offshore. Looks like coastal oil drilling, yes? Coastal oil drilling. Good, thank you, thank you. So the variable we're interested in is, are they in favor of it or not? It's kind of a flip a coin. Although they gave you a three-sided coin. Yes, no, no opinion. You can refrain to answer, which is also a choice. And we're asking Americans, according to that headline, yes? Good, very good. So let's look at the first one. U.S. oil drilling gains favor with Americans. That's this one right here. Americans' support for U.S. offshore drilling. Okay. Do you favor or oppose increasing offshore drilling for oil and gas in U.S. coastal areas? This seems like it's a fairly good question, I think. I don't think it leads anyway. It doesn't ask the question like, are you in favor of the barbaric practice that often leads to explosions? Something like that. Which you laugh. It's funny, you laugh, but if you watch incendiary news shows, they'll very often do that. You support hardened terrorists. Come after your family. I mean, you'll hear this kind of stuff, right? You'll hear this kind of stuff, and then how does the guest respond? No. I mean, you know, this is fairly, I think this is objective. This looks pretty good. Favor, oppose. So, okay, I saw 6 in 10 Americans favor increasing offshore drilling. Do you see the 6 in 10?
Yeah.
It's right there, isn't it? I have a question for Gallup. I think you made a mistake, Gallup. I don't think you meant 6 in 10 of all Americans favor increasing offshore drilling. I think you meant 6 in 10 of your polled sample favors offshore drilling. Because when they say 6 in 10 Americans favor increasing offshore drilling, I go to them and go, how the hell did you pull that off? You asked every single American if they favor or not, and you got that data? Hell yeah! Tell me your secret. But they don't mean that. What was their sample? What was their sample? Keep looking.
1,021.
Boom! It's down near the bottom, just like it, FYI, just like it is on the news. If it's there at all, it's at the bottom in 8.5.
That's not very many people.
That's okay. Is that Lauren?
Yeah.
Good. It doesn't seem like that many people. Believe it or not, it's enough if you can accept the margin of error on this poll, which is pretty standard. I love Lauren's point. It doesn't seem like many because there's so many Americans. The magic number, I think, I'm going to go by memory here, I think it's 1,067. Is that right? That can't be right.
That still doesn't seem, I mean...
It doesn't seem it, but mathematically it's all you need to guarantee a certain margin of error, a certain confidence. And if you, are you taking 244?
I don't know.
Yeah, you are. I don't want to jump to it. If you want after class, I can show you the math behind why it's okay. I'd be more than happy to. I don't do it right now because it's going to seem like magic. But all of this is based on algebra, and it's based on a set level of bell curve confidence. All of which we're going to get into in this course bit by bit. Right now it might seem like hand-waving, which I'm doing an Italian hand-waving thing. But I promise you that the number's okay. I'm not so much interested in the number as how they got the number. Did they get the number? In your opinion, okay? What do you think? Read more about that sample. So Richie went right to that 1,021 adults. Good. Read the whole sentence that went with it. Telephone interviews. We'll come back to that. 3 days worth, which is good because they actually update this every week and they keep a running average going. They keep what's called a moving average. We'll study that with my chicken egg production. We'll get back to that.
Continental U.S.
That's one thing that got my attention. The age 18 plus gets my attention first because, like, wait a minute, it said Americans. Now they're saying 18 plus Americans. Why do we care about them?
Because they'd be the voting population.
They vote. That's why politicians are going to care about that, because they vote. But that's not implied up there, is it? Now, of course, am I going to ask my 6-year-old, do you care if they drill in Alaska? I like drills. I mean, you know, you might not get a whole lot of data from a 6-year-old, so maybe it makes sense you've got 18 plus. But did you catch this?
The continental U.S.
The continental U.S. Where is a great chunk of coastline in America? In the non-continental U.S. I mean, granted, there's a bunch of coastline in the continental U.S. too. California's got a hell of a coastline. But as far as I know, there's no oil there. because it's filled up with volcanic fault that San Francisco is going to fall into. A lot of the coastline where we drill is in Alaska, in particular ANWR, which we'll get to momentarily. But yet they were decidedly removed from the sampling. So is that headline truly accurate? Maybe. Maybe I would put continental U.S. Americans in there to make it a little less misleading. Because it's not untrue, is it? But it's a little too truthy, right? It is Americans, right, Lauren? It's just not all of them. In other words, it's not a random sample of Americans. It's a pseudo-random sample of contiguous U.S. Americans. It's almost like saying light orange isn't really orange, but it is. You see what I'm saying? It's truthy. There's some hidden stuff in there. So I don't like that very much. That's why you gotta look down here. You gotta look down here and question that. Anyway, let's assume it's okay. Let's assume it's legit with that caveat of, they didn't ask Alaskans. They didn't ask Alaskans. I don't like that. The 1,021's okay. The problem I have is still with the fact that it's 60%. It's not 60%. Because that sample you drew does not exactly match the percentage of Americans out there's opinion about offshore drilling. It doesn't. It can't. There's no way that it exactly mathematically matched it. So what do we have to attach to that number to make it better?
Margin of error.
That's where what's called a, Jacob, right? Margin of error comes in. Every poll like this has one. Every poll like this has one. You often have to read very deeply to get to it. Can you see it? We're looking at it right here. This is, wait, Michelle?
Yes.
Bailey? Bailey's looking right at it. I saw her eyes go right to it. It's right there. Plus or minus 4 percentage points. That means you have to apply those numbers on the up and down of whatever number you see in this poll. You can't say that 60% of Americans think that offshore drilling is okay. You have to say that at least 56% of Americans and no more than 64% of Americans think that offshore drilling is okay. Because you can't get that kind of a precision from a random sample. You have what's called sampling error. And it happens. It's not a bad thing. A margin of error has to happen because if you run the sample again, you're going to get slightly different results. They're probably going to be close to that result, but they might be 59% or 61%. But you have to give it the plus or minus of that margin of error in order to be correct. Now, even with that taken care of, I still believe that more people favor than oppose. And that's because 60 to 37 is a huge gap. And even if you put 4 percentage points up and down, this is no less than what? 56? And no higher than 64, yeah? Oppose is no lower than 33, no higher than... So even this, at 41, is still lower than the favor at 56, yeah? So there's still a gap between there. So I agree that more favor than oppose. Just don't tell me it's 6 and 10. Don't tell me it's 6 and 10. It's around 6 and 10, yeah? This is why headlines like, the unemployment rate just jumped from 7.2% to 7.3%. No, it probably didn't. It's probably right around 7.5%, and it's fluctuating randomly in between there. Watch it on long-term trends, like you'll do with my chicken egg production, and you'll see long-term trends up here. But don't micromanage. This is what I call macro-managing, looking at the entire range of error. Fair? Good. So I do believe the claim. U.S. oil drilling gains favor, at least at this point in time, more favor than oppose. Do I agree that support for oil drilling and exploration in Alaska reached new highs? That's this question here. Do you think the ANWR in Alaska should or should not be opened up for oil exploration? Well, according to the headline, it sounds like they're saying yes. And if you look at the numbers, 49 is bigger than 45. Mathematically, yes, 49 is bigger than 45.
But when you put in the margin of error, they over.
But when you put the margin of error on, you can't tell which one is bigger. Because that's probably not 49. It might be as low as 45 or as high as 53. This one might be as low as, or as high as, and all of a sudden, this one might actually be higher than that one. And that's why this is inconclusive. Pay attention to your margins in your studies. They will tell you whether or not you can believe the slightly overhyped headlines. Honestly, this is what most Americans don't know how to do. And in all fairness to Americans, it's because the news doesn't give you the margins very often. I remember years ago, it was during one of the election cycles, 2000, 1996, one of those things, and there was constantly these freaking polls. Who's in the front? Who's in the front? Chris Christie just got tied to a scandal with traffic in New York City, and now he's out of 2016 race. Oh my God, it's starting already, right? But what they do is they put up the percentage of support for all these candidates. You know, 32%, 33%, 36%. Oh, 36% clearly in the lead. Is it? Is it? Did you put a margin on there? Oh wait, where's the margin? So I started emailing CNN. Like, would you please put the friggin' sampling error on your polls? Please. And every week I would send another email. This was before I had a kid, so I had more time to do stuff like this. Eventually, and I would take credit for this because it was all me, the margin started showing up on the polls. I'm sure it was pissing a lot of people off. Because basically, and I said, I think I told you this yesterday, I blame 24-hour news. They have to fill it with stuff to be 24 hours. So they fill it with meaningless stuff, essentially. As soon as you put the margins on, you can realize their headlines are somewhat untruthful. There's no difference between 32 and 36 if the margin's 3% or 4%. But most Americans don't know how to use it. Guess what? You do now. Isn't that wonderful? Please, Serenity.
So you're saying with every, like, actual scientific sampling, which is the 1,000,
It has to have a margin of error.
And that margin of error is always 4%.
If we're set at 95% confidence.
Okay.
That's the kicker. There's two things that work, and this is what I was getting to with Lauren. It's going to seem a little hand-wavy right now. Your poll might, remember how you walked in and said, it took me an extra hour to get here today? I called you an outlier.
Right.
It's possible to draw outlier results randomly, as in, well. So for example, suppose I want to take a random sample of size 1 of all of you and find out on average how much longer it took you to get here than it usually does today. Now, chances are I'm not going to pick you because you're one of 35. But suppose I do pick you, right? Then I get a kind of misleading data point, and I build my study on that data point. I was told there's an anthropological study about a certain ancient race of human that's entirely based off of one skull. One skull. Now that one skull, an entire like series of documents have been created based on this one skull. What if that one skull was like me? You know, right? Like what if it's the oddball? And we're exactly how it's like an alien coming down to Earth and seeing my punk rock friends in New York City. My God, humans have blue hair that sticks straight up 3 feet. I mean, you know, it's not likely, but what if we get that one? That's what the confidence measures. You can set how likely you want it to be that you're actually close to where you want to be. You can't get to 100% for reasons we'll study in this class. But the higher you get, the better. 95 is fairly standard in statistical studies, and we'll talk about why again in 243 and mostly 244.
So if you had, in your case that you're talking about, if you had her as your outlier, your confidence would be lower?
Well, the confidence actually guarantees I'm going to have an outlier somewhere.
Okay.
It just guarantees that Serenity would be that.
Okay.
Although, Lauren, you might be well within the hump of 95%. That's not unusual. Does that make sense? Yeah, the confidence is a good thing. High confidence is good. I just can't get to 100 for reasons you'll see mathematically. Yeah, I'm getting a little ahead of ourselves there with 244-ish stuff, but don't get wrapped too much up in it right
Well,
now.
also, I'm thinking about, so if there's a bell curve and we cut off at a certain point, right?
Yes, which is what the confidence is.
Okay, so that is your...
You have a bell curve,
Got it.
starting in the middle and working your way out. As you work out, you pick up more and more confidence, which means it gets harder and harder to get outside of where you've picked off.
As you get outside...
It gets harder to get in the tails, because you've got more confidence, less what's called significance.
Okay.
If this bell curve talk doesn't make any sense, don't worry, it shouldn't at this point. It really shouldn't. And I think a lot of times we get into bell curves too much in other classes too soon, without understanding A, why they're shaped like that, B, the fact they never pinch off, and C, what the areas actually imply. I promise we'll get to that soon, like I is in Tuesday, and we'll start uncovering it as we go. But thank you, Serenity, for that. Very good points. That's very good. Other questions? Fantastic. Read deeply. I mean, you have to read this stuff deep and realize too, before we move on, I'm only showing you a teeny little bit of this survey. It was pages long, and I extracted this bit from it. So you have to realize what you're getting into when you look at these studies. They're quite deep sometimes. All right, let's take a step back. You just saw a bunch of data presented in a bunch of different ways, and there are many, many, many more. And in the front part of your textbook, there are even more that we're going to look at right now. What I want to do right now is I want to look only at, well, we'll get to that in a second. 2 minutes, we'll talk about the ones I want to look at. Suppose you have this data. I just made up some random numbers here. 20 random values. When you have them given to you like this, I call them raw data. On your quiz next week, should you choose to do the prerequisite quiz, you've got a block, I think, of 100 numbers dropped into a big grid, and you'll see how to deal with those in Excel. Raw data is always the best to have. It's always the best to have raw, because that's everything that happened. Now, whether or not it was taken well is another story. This was randomly generated data for the most part. I gave it a little bit of context. This is raw data, and that's fantastic. Is there any problem with, suppose you gotta give this to your boss. This is how your company's doing. Take the paper, hand it to him like that. Is there any problem with handing your boss these 20 numbers in this format?
Hard to read.
Why is it hard to read, Richie?
It was just numbers all over the place.
I like the argument there. It's hard to read because the numbers are in no detectable order, so they can definitely be kind of all over the place. Lauren, go ahead.
They don't necessarily define what the numbers are.
That's okay. I made up a context of their products made by a company. I would do a better job of doing that, obviously. But I want to focus on just the numbers, not their meaning right now, just the numbers. And thank you, though. That's 100% important, defining your variable. Anything else?
Well, it doesn't say which
Michelle.
employee did which production.
Good, very good. It doesn't tie an employee to a number. You would have that theoretically. You would have that correlation. You would. Good. Okay, good. Now, so realize there's a good, an upside and a downside. It's good because this is what you have. It's bad because it's a little bit clustered. Could we put them in order?
Yeah.
We could definitely do that. But you still have 20 values. And imagine, for example, you've got like on your quiz next week where you have 100 values. Or that Gallup poll, you have 1,021 values. It's going to start getting hard to look at them individually like that. It's going to be nicer to collate them together. So one way to do that is called a distribution. So this is the same random values, or the same set of values right here. This up here is another way of looking at them. Take a look at that and see if you can see how that is telling you-ish the same thing that you're getting down here. For example, number of products, 10 through 12. Why is that 1? Because, say that again, I'm sorry.
One person created 10 to 12 products.
Exactly, it's that person right there. That person created 10. There are no 11s and there are no 12. So one person was in the range of 10 through 12. I picked 3 wide just on a whim. You can make them 4 wide or 5 wide or 2 wide. We'll mess with that constantly in this class. I just decided to do it with 3 wide for this one. And messing with those widths is one of the finer points of statistics, being able to figure out which is the best width to visualize data. We're going to mess with it for 10 weeks, if not 20 in 244. Do you see why, for example, 19 through 21 is 5? Right? Let's count here. 21, 20, 19, 19, 21. There's your 5. Now, why is this nicer? If you think it's nice, you might not like this. Those of you that think this is a little more organized, why is it nicer? Besides the fact that it's more organized.
Well, you can see the frequency.
Say that again, Lauren.
The frequency.
Good, you have an idea of where the majority of things are. You know there's 20 things, and half of them are between 16 and 21. That wasn't purely obvious on the first page at all, that half of them are between 16 and 21. Very good, very good. How is it not as good as the raw data? Because remember, you don't get both. You generally won't get this, you'll get this. Or you generally won't get this, you'll get this. So, take this away, what do we lose here?
It causes you to make assumptions about the data.
Good, what assumptions in particular?
Well, you don't know the exact number of items produced.
Right! All we know is one person made between 10 and 12. Was it a 10? Was it an 11? Was it a 12?
And then
Believe it.
5 made 16 to 18.
Right, where are they? Are they all 16s? Are they all 18s? Are they split roughly evenly? We have a solution for this. We'll deal with it on Monday, or Tuesday, I promise you. But that is a concern. You no longer have the exact values, which could be a little bit disconcerting. Although I think we'll fix that problem on Tuesday. Thank you. Now, this is great, and it's called a distribution, and it's wonderful. But it seems to be that human beings, at least the American human beings that I know pretty well, like that representation of it better.
Oh yeah.
That's what's technically called a histogram. A histogram. Okay, now a histogram is wonderful. Why? How is a histogram wonderful compared to this? How is it the same? How is it different? Why is it better? Why is it worse? Your guys pick. How do you feel? I like it better, but I have my own reasons. I want to hear your reasons. Do you like it better or do you like it worse? Holden, what are you thinking?
I like it better. It's just more visually capturing.
Okay, I like that. It's good. We like the visual. We see graphics all the time. Who's in front of you, Holden? What's your name?
Sarah.
Sarah, go.
I was gonna say the same thing as him, pretty much, and just like I mean, it's easy to read and yeah, the visuals.
I think so, and I've noticed a correlation between students that study algebra and the like of histograms, and I think here's why. Students seem to hate t-tables in algebra class, but they love the graphs they make with the t-tables. Like y equals 2x. 1, 2, 3, 4, 5, 6. But then you graph this line with a slope of 2, and you're like, oh, there it is. There 1 is. But it's the same thing, but for some reason, putting that second dimension on there putting that second dimension on there makes it more appealing. Others, please! Why is it better, Michelle?
You can get the information maybe that you're looking for faster than you could in the T.
This is why I like it. Remember how he said, Holton pointed out there were 5 between 16 and 18? You can see that 5 right here. And there's a bit more of a wow factor because that bar is 5 times as big as this one bar. You don't have that scaling in the actual T-table because the numbers are the same width. 0 is the same as 1, is the same as 2, is the same as 3. When you go to double digits, you might pick it up a little bit. But still, not in the scaled way. So yeah, I'm with you. I like this because of that. The holes drop out very nicely and visually. The zeros are gone. You see that there's a pocket here, and a small pocket there. That might fill in if we had more numbers. That might actually fill in and make something looking more like a bell. I'm not sure. We can look at that too. But yeah, you get this. There's 50% of the data right there. Yeah, so I like histograms. I like them. We're going to use them a lot in this class. We're going to use distributions too. I like these because we can do math on these very directly. Whereas we have to make an intermediate step with these, but we can deal with both, and we will deal with both as we go through the course, I promise you. We'll do them in Excel, we'll do them in the TI, it'll be good. What I want to do now is I want to focus on histograms for a little bit. I want to focus on these guys, but I want to generate some that they're related to histograms, but they're not exactly called histograms. And I want to try to tell you why you want variance on them. And we're going to talk about 3 in particular that are my favorites, and the ones that are most common in the world. First one's called a Pareto diagram or a Pareto chart. I want to collect some data for this one though. I'm going to pause the camera and start it up again.